Black holes are one of the most mysterious and powerful entities in our universe, and in this video, we'll explore one of the most groundbreaking theories about them, Hawking radiation. So, what is Hawking radiation? Well, it's the radiation that a black body, such as black holes, produce. This radiation was hypothesized by one of the most prominent figures in physics, the late Stephen Hawking. So, how do black holes actually emit things? Well, first of all, in quantum physics, empty space is not empty. It's actually filled with quantum fields which fluctuate, and particles are units of that fluctuation. When we get near a black hole, these fields stretch across both sides of the horizon. This horizon basically messes with the quantum fields in a wacky way, and this is the weirdest part. Someone who is falling into a black hole would see nothing, but someone who is watching outside would see real particles being emitted from the quantum fields. This is because the weird stretching of the quantum field wavelength makes space seem different. What it does is that what seems like nothing to the person falling in is actually a particle to the observer outside. These are the issues that arise with such logic-defying entities, such as black holes. But what do they actually emit? Well, first we need to know about the Hawking temperature. We now know that black holes warp space-time and quantum fields around it, and this leads to what we call a redshift pattern. This pattern produces thermal radiation. When we compute this particle flux, we get a temperature of the radiation around the curvature of the black hole. Basically the temperature of the black hole. This temperature increases when we have a smaller black hole, and this temperature decides what the black hole radiates. Now, from established theories, all black holes emit massless particles like photons and gravitons, which we discussed in a previous video. Then, there are the almost massless particles like neutrinos, which we'll talk about in another video. Then, we have even more massive particles like electrons, protons, and neutrons. Some black holes emit gluons as well, in a jet such as in this visualization. Basically, the higher the temperature, or the smaller the black hole is, the heavier the particles they release. This is why most small black holes evaporate quicker than big ones. Overall, we have discussed Hawking radiation, quantum fields and space-time warping, Hawking temperature, and which particles are actually released by black holes. I hope you guys enjoyed this video. If you did, make sure to like and subscribe, and as always, stay curious like a child. The world needs more of it. Bye.